Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 5.1.2. We're going to start with our M&Ms, which talk about equivalent equations. And I just want to make sure everyone understands the connection here. When we were learning about equivalent fractions, if I said 2/3 and I wanted to create an equivalent fraction, we would use the giant 1. So maybe the giant 1 would be a 5/5. And so that meant that you're multiplying the numerator times the same number that you're multiplying times the denominator. And that's how we get an equivalent fraction. Same thing applies for when we're working with equivalent equations. If I take x plus 1 is equal to 5, and I decide I'm going to multiply every single term in that equation times 2, it would create an equation that said 2x plus 2 is now equal to 10. These two equations are equivalent to each other because x would be equal to 4 here because 4 plus 1 is 5, and it would also be equal to 4 here because 2 times 4 is 8 plus 2 is 10. So when you multiply every single term in an equation times the same number, you get an equivalent equation to the original. And that's what we've been working with from the very beginning, right? If I wanted to take 2 away from each side and then divide by 2, I would get my solution. Or I could start by dividing everything by 2, and it would bring us to here, and then subtract 1, and that would give us our solution. So we've been working with equivalent equations for a long time. We just haven't done this fraction or decimal buster process to get those equivalent equations. So here are examples of equivalent equations. And remember, you get there by either adding whatever you add to one side, add the same thing to the other. You can get there by subtracting. Whatever you subtract from one side, subtract the same thing from the other. The same thing applies for multiplying and dividing. You end up rewriting your equations in a different form that eventually make it easier to figure out the answer. So all of these are examples of equivalent equations to the original 2x plus 1 is equal to 3. In this case, we multiplied everything times 10. In this case, we divided everything by 3. In this case, what did we do? We just factored out the 2. And in this case, we multiplied everything times 1/1000th. But all equivalent. If we were to solve for x in all 4 of those, we would get the same answer every single time. X would be equal to 1 in all of these situations. So let's use our understanding of how we can rewrite equations to make them easier to solve and then solve the equation. In this case, the solution is 10.5. If we wanted to rewrite this equation, I would multiply everything here by, what could I do? The 6, right? If I multiply everything times 6, then 6 divided by 2 is 3, so that becomes 3x. 6 divided by 6 is 1, so that cancels out the 6's in this one, and then nothing cancels here, so that ends up giving us 42. So 4x's is equal to 42, and when you divide 42 by 4, you get 10 and a half. Now, if we were to check that, it's not the easiest one to check, because I don't like 10.5 as our solution, but if we were to check it, we would see that as the correct answer. I'm going to wimp out because I don't want to take too much time and I don't want you to be bored. All right, let's look at this one right here. What would we multiply everything by? It looks like, I think 18 ends up being that number. So if I multiplied everything times 2 and times 3 and then times 3 again, let's do that. 2 times 3 times 3. 2 times 3 times 3. And then 2 times 3 times 3. Why did I do the 3 times the 3? Because these two need to cancel out the 9, leaving you with 2 times x. The 2 cancels out here. Actually, it would have canceled out there as well, but let's not do that. So this becomes 3 times 3 times 2, which is 18, so it becomes 18x. And then here, one of the 3's cancels out, leaving you with 2 times 3 is 6. So you get 20x is equal to 6. And when you take and divide 20 on both sides, x has to be equal to 6 over 20, which can be simplified down to 3 over 10. And nobody wants to check that either, because that's a horrible, horrible kind of a check to have to do. But if you want to get the answer right, you should check it. All right, moving on. Fisher thinks that any two lines must have an intersection point. And the question is he correct? If not, provide the counter example. So this is like, if you're going to justify or prove that a hypothesis is correct, you've got to come up with evidence to support that. But then once you find a single counterexample that proves that it's wrong, then you know that the hypothesis is not true. So this hypothesis is not true. And here's the counterexample. Two lines don't always have to intersect. Parallel lines do not intersect. So if we had two different lines, let's say one was y equals 2x plus 3, and the other one was y was equal to 2x minus 1, both of these lines are going to have the same growth rate, so they're both going to be parallel to each other. Let me just do a very, very quick, without labeling things. We do it something like this. So let's do this one will be the red one. So the y-intercept is at 3, and then it goes up 2, and that would be the line for the first one. This one we'll do in blue. So this has a y-intercept of -1, but then up 2, 1 to the right, up 2, 1 to the right, up 2, 1 to the right, up 2, 1 to the right. Those two have the same exact slope. So stop it. So they will never intersect each other, because two lines with the same slope, turns out they are parallel lines. They can't intersect each other. So there's your counterexample. 5D process kind of a problem. In the last election, candidate B received twice as many votes as candidate A, and candidate C received 15,000 fewer votes than candidate A. So it looks like both of them are being compared to candidate A. So candidate A looks like the logical choice to be our X. So B received twice as much, and C was 15,000 less than candidate A. So that's X minus 15,000. So when we take those three expressions and add them together, that gives us the total number of votes that were cast. So if we want to figure out how many candidate B got, then we're going to have to solve for X and then double that number, and that will tell us what B has. If you had wanted to, you could have done this. You could have said candidate B would be your X. And it's nice to do that since we're trying to find the answer to candidate B, so that when we solve the equation, we'll have our answer. The problem is, then you'd have to say this is X divided by 2, and this one would have to be X divided by 2 minus 15,000, and nobody wants to solve that equation. So let's not do that. Let's just do this instead. So we end up with X, 2 X's, 4 X's minus 15,000 is equal to 109,000. And now we need to cancel this negative 15,000 out by adding 15,000 to it. So what is 109 plus 15? That is 124,000. And so when we take that and divide it by 4, 12 divided by 4 is 3, so that's going to be 31. So X is equal to 31,000. Now, I don't want to just say if X is 31,000, then 2 X's, which is candidate B, would be 62,000 without first double checking to make sure that I've got everything correct. So remember, candidate A was X, so that's 31,000. Candidate B has to be twice that, which is 62,000. And then candidate C was 15,000 less than that, so that would be 16,000. So if we add all those together and they equal 109,000, then we know we're correct. So 0, 0, 0. That's a 9, that's a good sign, that's a 10, that is perfect. That's what we want. So we can declare the answer is 6,000 or 62,000 votes for candidate B. That was candidate B right here. Jamila wants to play a game called Guess My Line. She gives you the following tips or hint. 2 points on my line are 1, 1, and 2, 4. So if we want to figure out what the growth rate is for that situation, we just have to figure out what is the change in y over the change in x. So to go from here to here, the change in y looks like it goes up by 3, and the change in x looks like it increases by 1. So that means that the growth rate, or m, is equal to 3. If m is equal to 3, and these two points are on the line, then there's a way you can do this actually without graphing to find the y-intercept. This is how it works. Remember, y is equal to mx plus b is the formula. We know that m is equal to 3, so I'm going to plug that number in right here. If I take this point or this point, it doesn't matter which one I take. I'll just do this one and call this the x and this the y. Then we have 1 is equal to 3 times 1 plus b. So that means that 1 is equal to 3 plus b. Well, what number do you add to 3 to give you 1 for an answer? Well, if we solve this algebraically, you'll see that b has to be equal to -2. So that's going to be your y-intercept. Now let's go and verify that on the coordinate grid. We know that these are our 2 points. We know that the rise over the run is 3 over 1. So to go from here to here, you go up 3 and 1 to the right, up 3 and 1 to the right. But if you want to go down, you'd go down 3, 1 to the left, down 3, 1 to the left. And looky right there. That's our y-intercept. It matches that right there. So we proved it 2 different ways. We proved it algebraically, and we showed it to be true on a graph. All right. Is this the last problem? Yes, it is. Solving for the variable. All of these problems involve distributive property. Use the distributive property first. And once you've done that, then you just combine like terms and then start the process of adding and removing balanced sets. I will do C, since I think probably a few people might have gotten this wrong. That seems to be one that's common to get wrong. That negative sign in front of the parentheses means you need to change both of those terms on the inside to their opposites. Now we can combine like terms, and the 2 like terms are the 2 and the -2, which cancel each other out, which end up giving you -y is equal to 3y's. What do we do now? Well, remember, we're trying to solve this equation. So what we want to do is we want to collect our y's on one side of the equation. So if I add a y here, I also have to add a y here, and that's a legal move because you're doing the same thing to both sides of the equation. You're going to create an equivalent equation, but this zeroes out, leaving you with nothing. This side gives you 4 times y. So at this point, people start getting confused as well, but it's really straightforward. What do you multiply times 4 to give you 0 for an answer? The answer is 0. So if you divide each side by 4, 0 in the numerator means it doesn't matter what your denominator is as long as it's not a 0 in the denominator. 0 in the numerator means your answer is 0. So y is equal to 0. Now let's check that to prove that that's the case. Is 2 minus 2 equal to 3 times 0? Right? I just went ahead and added the 0 to the 2 there to make that 2. And there would be parentheses there, but you don't really need it. 2 minus 2 is 0, and 3 times 0 is 0, so that checks out. That is the correct answer. All right, so I'm not going to do the others, but if you wanted me to work out any of the others, you could send me an email, you could contact me, and I would go ahead and work those out for you. But these are, in fact, the correct answers, and they have been checked. All right, so enough of that. 13, almost 14 minutes. All right, let's move on to the next activity. Take care. Bye. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,